Hello class. So I know that a lot of you are having a hard time with like linear programming, and I was too, and some of y'all asked me to make a video on it, so here I am. This will be my attempt to try to teach it, or at least help you understand it better. So basically the way linear programming works is it's like the solving linear equalities, but with a little, some extra steps. So you're going to be seeing a lot of this kind of graph. An important thing you need to know is that you're only focusing on the first quadrant, which is the top right corner of the graph, instead of the entire, the entire axes, because this is where both x and y are positive. And you're going to see lines, here, I'll draw a smaller one here. You're going to see lines that intersect and make this sort of little box here, or this shape. It's not a box, I don't know, quadrilateral or whatever. But basically, yeah, you're gonna get something like this, and it's gonna be shaded like I have here. It's gonna be shaded into this section, and the important thing about linear programming are these vertices, and the vertices are where like it changes direction, or where there's an intersect. So in this case, there's I mean 0, 0 always counts, but kind of disregard that because that's always just 0. There's one here on this graph. There's one here. There's another one here at where the two lines intersect, and there's one here where this line hits the x-axis. All three of those are what we would call vertices. And that's how we solve this pretty much. So I'm gonna help you guys. I'm gonna go through example 4 on page 385 if you want to follow along. So a company makes 2 models of MP3 players. The M20 takes 3 hours to manufacture, and the M25 takes 1 hour. The company has multiple shifts and has a 20-hour day for manufacturing the players. The M20 generates a profit of $12, and the M25 a profit of $7. The M20 uses 15 special chips, while the M25 uses 10. For the next manufacturing cycle, consisting of 18 days, there are 3,000 chips available. How many of each type of MP3 player should the company produce to maximize its profits? What combination of MP3 players would result in the least amount of profit? All right, so we just have to look at, what it gives us and sort of group it together, because the way they give it to you in this problem just kind of jumbles it around. So let's take a first look at how long it takes. Well, actually, first of all, let's just say the piece of paper. The M20 is X, and it takes 3 hours to produce. So we'll say 3X for the M20, and the M25 is 1 hour, so we'll make that Y. So 3X plus Y. And here's another thing we have to look at. It says they have 20-hour days, and they have 18 days. So 18 times 20 is 360. So that's the total amount of hours. Yeah, total amount of hours. So we would say 3x plus y, because these are both in hours, is less than or equal to 360. So this is one of the lines that we're going to be drawing, one of these, and we'll get back to that. But that's only one. We need another one. Okay, so let's see. The M20 uses 15 special chips, while the M25 uses 10. For the next manufacturing cycle consisting of 18 days, there are 3,000 chips available. So let's look back. The M20, which we just said was X, it uses 15 special chips. So we'll say 15X plus, and the M25 uses 10. So 10Y is less than or equal to 3,000, because it says there are 3,000 total chips available. All right, so we have this. This is a good step. But the last thing we need to do is we need to get what's called the objective function, which is, it's not something we graph, it's something that we plug the results of the graph into. And usually it's like the equation for profit, or how much you're going to be like making, how much money. And in this case, it says the M20 generates a profit of $12, and the M25 a profit of $7. So we can write here, so profit equals, so $12 for the M20, which was X, so 12X, and $7 for the M25, so plus 7Y. So this is what we would call our objective function. All right, so now we would graph it, and I've already spared the time of you graphing this. Basically, a cool tip, when it comes to graphing, like the actual lines, just disregard the less than or equal to for now. Just say it's an equal sign. And if you make like the y 0 and then solve for x, you would get x equals 300 and x equals 120. So you would, handy little trick you could do, because y was 0, x is 120, you can plot that on the graph, and then you can do the same for x. It's just a lot easier than like flipping it all around and like solving it for y. If you just make one of the variables 0 and then solve for the other variable. But basically, what we end up getting is a graph that looks like this. I haven't shaded it yet, but I'll come back to that. If you remember back to the linear inequalities video, I said that when y is less than something, you always shade down. And because, if you math these out, y is going to be less than, so you would both shade it down. So in this case, this area right here is the darker shaded area, and what we would call the feasible region, which is like the area in which all the possible solutions are. So I'm just gonna very crudely shade this in. All right, so now that that's been shaded, let's take a look at what the graph gives us. So we have, first of all, we need to identify the vertices. So there's one here at 0, 0. There's one up here at 0, 300. There's one where these two lines intersect right here, and that's at 40, 240, so right here. And there's another one right here at 120, 0. So we've identified the vertices. Now what we have to do is we need to come back to our profit equation, or the objective equation here, which is 12x plus 7y. I'll write that here, 12x plus 7y. Now we need to take the vertices, and the vertices only, and we need to plug them into the objective function. So if we take our points, 0, 0, it's just going to be 0. Here, I'll make a chart. 0, 0, x, y. You're going to get 0. Okay, 0, 300, which is this point right here, this vertice, I don't know how to say that, is 0, 300. If you multiply this out, you can use your calculator, you get 2,100, which is pretty good. This is the total amount of profit you'd be making if you just made 300 of the M25s. Next we have this point here, which is 40, 240, which is 2,160. Next you have 120, 0 right here, which 120, 0, which you get 1,440. And now all we have to do is we just see which one of these was highest. And in this case, it was this one right here, 2,160, which was the point 40, 240, or this intersection, this vertice right here. So how much of each type of MP3 player should the company produce to maximize its profits? You should make 40 of the M20 model and 240 of the M25 to maximize your profits. Now it also says what combination would result in the least amount of profit. Well, if we look back at our numbers here, sorry if you can't read this, I wrote it kind of small. We have 2100. We already said this was the max, 2160, and we have 1440, which, if my math is correct, is lower than 2100. So we would say that in order to make the least amount of profit, you would make 120 of the M20 models and make 0 of the M25. So the final answer would be, well, you would just write 40, 240 as the point, and then just like is the max, maximum. I'll just put max for now. So that's how you would do this. All right, let's do another problem. Okay, we're gonna do B from the lesson practice on page 386. All right, so it says a caterer needs to prepare 2 different meals for a conference dinner. One is a chicken dish and the other is a seafood dish. The chicken dish costs $2.50 to prepare and the seafood dish costs $3.75. There will at most be 1,000 people attending. Usually twice as many people order chicken than do fish. How can the caterer keep costs to a minimum while still making sure that most people get their meal choice? All right, well, let's just take a look at what it gives us. So let's find the objective function, the cost function first, because that's, that's the first thing it gives us. So it says the chicken dish, which we will give X, costs $2.50 to prepare. So we'll say C for cost equals 2.50X plus, and then the other one was 3.75, so we'll give that y, so 3.75 y. All right, now the next thing that it gives us, the next thing that it gives us is there will at most be 1,000 people attending. And this is pretty simple. You just take, x plus y, or like the people that would order chicken plus the people that would order fish, and that's going to be at most 1,000. So you would take x plus y and make that less than or equal to 1,000. The next thing it says is usually twice as many people order chicken than do fish. This means that there are twice as many chicken orders, which means that we would take chicken orders, and that is equal to 2 times the seafood orders. So x equals 2y. All right, now let's take a graph. I kind of used this for a previous take of this, so if you see stuff on here, just me erasing. All right, so we have our information here, and let's graph it. First, in order to do that, we have to solve for y. I mean, these ones aren't complicated enough where we can just put a 0 in and do that, although we could if we wanted, but I'm not going to do that. So for this one, we would divide both sides by 2, and we would get 1/2 x equals y. So 1/2 x equals y. Let me just get the old calculator in here because I'm too lazy to do this by hand. So 200x would be 100y, 400x would be 200y, and so on and so forth to infinity and beyond. So let's just graph this out. Just a nice old line. Also, I don't have a ruler, so I'm just using a random card that I found on my desk as a straight edge. All right, we have line. Now we have to graph the other one. X plus y is less than or equal to 1,000. If we just flip this around, we get y is less than or equal to negative x plus 1,000. When it comes to first graphing the line, you can just treat the inequality like an equal sign. So when we're graphing this, we would start at 1,000 and come downward like this. All right, so we have line. We have 2 lines. Now this one would shade down because it's y is less than. So let's just shade this down real quick. All right, this is our feasible region. Now, like I said originally, we have to take a look at the vertices because the vertices are really important. So the first vertices that we have is 0, 1,000 up here. So let's make a little table. So 0, 1,000. We have another one right here, which, if you can't read it off the graph, is 666.6 repeating, and then 333. Now the next one is, there's 0, 0. Oh, and then there's this one that'll come down and hit the x at about 1,000. So we have 1,000, 0. All right, now, like I said before, we just have to plug this back into our original. Okay, I'm gonna let you guys in on a little secret. So basically, when you have 2 that intersect like this, the intersection is like always the maximum, or like always the best choice. So in this case, I'm just gonna skip over plugging it in, and I'm just gonna tell you guys that this point right here is the best solution, which was 666, which was this. So, what we can assume from this is that there will be 667, because we're rounding up, chicken meals, and 333 seafood meals. In order to find the intersection point a little easier, a little calculator trick is to plug these in. So negative x plus 1,000, and y equals 1/2 x. All right, a little thing you can do in your calculator is if you graph them and you find where they intersect, you can go to second calculate, go down to intersect, you press enter, and you just press enter 3 times. And then for the guess, you just move the little cursor right to the center. You press enter. And here we have the intersection point, which, like I said, was 666.6 repeating. And then the y is 333. So, and like I said, this point is like always the right choice if you're going for like maximum. So, in this case, the correct answer would be, in order to maximize profit, you would have 667 chicken and 333 seafood to round. All right. I know that this probably doesn't cover everything, but it should be most things. Like I said, I'm still understanding this myself, and this is just everything that I know. If you guys have any questions, let me know, or ask sister, because she's kind of our math teacher. But yeah, this is mainly how it works. This was my attempt to teach it. Hope you guys enjoyed, and I'll see y'all tomorrow. Thank you.